Const is a C++ keyword, and as the keyword it's spelled with a lowercase c. It means that you promise you won't change a value. That might be because you simply want to impose a little rigor on yourself, or it might be that you're being given a value that you're not allowed to change and you have to promise that you won't. So you can declare a local variable like this, const int 0 equals 0. And any code that tries to set 0 to 10 or minus 3 will trigger a compiler error. It's not allowed to be changed. You can take a function. Foo here can take a const integer I. That's a semi-pointless thing to do, right? Because I here is being passed by value, and any changes you make, you'll only be changing inside foo, and who cares, because they'll be thrown away when foo goes out of scope. But the second line, something, takes a const person reference p. And we've said a couple times, when you pass something by reference, someone can reach through the reference and change the value back in the calling code. Taking a const reference says, actually, I won't. It means I'm taking this by reference because the cost of a copy might be expensive. You know, when you take a function parameter by value, that integer or that person or that insurance policy or whatever is copied into a temporary that's given to the function, and that may be a very expensive copy. Passing by reference prevents the copy, but it enables someone to change the real object back in the calling code. And if you don't want that, then you write const person reference p. What will happen now is when the compiler compiles something, if any code in it changes p, you'll get a compiler error. So it's a very safe way to say, I'm giving you a reference to spare the copy, but this doesn't mean that you can actually make changes back in my code. Imagine that I take that person p as a const reference and I call some member function on it, like getName or getNumber. Unless the compiler knows that those member functions don't change any of the member variables of person, it won't allow you to make the function call. You have to give it that reassurance, and you do that this way. This says that the getName function won't change any of the member variables of the class. That makes them safe to call on a const reference. So if we have a const person or a const person reference or whatever, call p, and we want to call p.getName, that's safe to do as long as the compiler knows that getName is a const function. That won't change any of the member variables of p. As you can imagine, getting all your consts lined up can be a challenge. It's called const correctness. So if our function something takes a const person reference and the code for something calls p.getName, getName has to be const. Well, getName's really simple. You've met person in lots of these demos. You know that all it does is return the first name and the last name tag together. But what if it called another member function? Well, then that member function would have to have const on it. And some of the functions may take parameters that need to be labeled as const whatever reference to make sure they're not getting changed. If you leave const correctness till the end of your development, it can just drive you crazy. But if you do it as you're writing, it can actually be a supportive framework that helps you to write higher quality code.